Hello, Orhan here with my partner Billy and Vsauce. So, in this problem 1, we have Bayes function, which we got straight from the notes. And as you can see, here it is. And I will run it. You have to run this one first. And we got this set of numbers from the bottom here. And if we run it, it is correct. Now I will also run top numbers. And if we run it, this one's also correct. Bayes function is pretty obvious. Now for our expected value function. This one was a bit more complex as we needed to use a loop in the function since it's multiplying a set of numbers by each other. And we have to iterate through said set. So, if I run this one first, and then our output, we get the correct answer for this expected value. Now, I will also run this one, just to prove we also get said correct output. Now for the shebang, and I have to run every single one of these. Now for a move function, we instantiated all of our variables up top right here. So for our square size, we divided our grid size by the number of squares, square num. And for each cell, as in barrier, in our game, we used our getCell function with each individual parameter inside set function to then produce each cell in there at random, of course. And as obvious, for our left function, which is a row, so is our right function as well. We multiply the cell of 1 times the square size. And as for our right function as well, we multiply it, and we added the square size to that. And then for our column functions, which is our top and down functions, or below, we added each of them as well to the sum of the cell of 0 and the cell of 0 with the square size. Now for our movement functions. So first we start off with an if statement for our left key, and we check if it's a positive integer from the beginning, and if it is, we move on to this if statement right here. We move left, and the x position, which equals left, so this returns true if the moveL position is more than 0, and we go into said if statement with moveL, which we do our algorithm as of here. So our grid cell, which is a parameter of each individual cell, -1, which gives us our left motion in our game. And we set it to 0. And then we move on to our not function in this case. So if the moveL and not position y is equal to top, then we won't be able to move with this said function because we aren't trying to go past each individual cell and or the barrier of the game window itself. And as of basic arithmetic, if this returns true, then we subtract the distance. Our x position is equal to our distance subtracted by our x position, which is this yes, because we're moving left. And this holds true for each individual movement. So right, up, down, all have the same logic behind them. Now I will run this one. And finally run our actual tester for this. Oh, I hope we get lucky, and we did not. So, as you can see here, let's just close that off. And we have to run each individual. It is. Well, and let's run this again, and we got lucky this time. So, I am mashing my left key, and it cannot go out of the window. I'm mashing my above key, and it cannot move out of the window. But I can move right, and I can move down, I can move up, and I can move left again, if I'm not in the window, right? So I will attempt to traverse through this maze. And as you can see, whoops, I cannot go through said wall. And, whoops, I cannot go through said wall. But I can go through the space right there. And can't go through that space right there either. And this concludes Orhan Nebi's and William Barnett's project for coding assignment 4 for MAT227. All right, thank you.